CASA is concerned about aircraft control cable failures because they shouldn't be happening. If the world is as it should be, and if cables are being examined as they should be and inspected as they should be, all the inspection procedures and programs should be in place to prevent it. What we're finding is that cables have not been inspected as thoroughly as they should be. We have, in the last 15 or so years, having moved away from major inspections, moved into a regime where cables and their systems, the terminals and all the wheels and pulleys and guides are being inspected in situ. And there was a time when we were doing major inspections where the requirement was to remove the cables, lay them out on the bench and inspect them, particularly where they went over pulleys or over fair leads, to check for wear and fatigue, and to open up the cables, bird cage the cables, that is, reverse against the thread of the cable or the wind of the cable to open it up so you could peer inside and see what kind of wear there was there. But that's not been happening. We have drifted into a situation where we have been reliant on cables and terminals being inspected in situ, and it's proving inadequate, and we are seeing failures, and we are seeing increasing number of failures even for our small fleet here in Australia. One of the interesting places that cables have worn has been on rudder cables where you could where the pulley is not really engaging heavily on the pulley, and the pulley looks like it's been turning under the influence of engine vibration, just been turning in flight, just rotating slowly while the cable's been essentially stable and in the one position. And we found some close to failures there. Fortunately, the lamies were able to pick them up. So the main places you'll find cables wearing is over pulleys and around fair leads. It was cable terminals, I think, that started me down the long path of the campaigning for changing cables out. And I think it was that Beechcraft terminal which failed in the aileron system of a Beech 35, where the aircraft was put into an immediate snap roll, and the only way the pilot could recover was by lowering the gear, reducing the power and putting in full left rudder or right rudder, I can't remember which, to overcome the effect of the bias springs which are in the Beechcraft control system. Then we started to look at other control terminal failures, and reports started to increase over the last few years, and we're becoming more and more concerned about the number of control cable terminal failures due to chloride stress corrosion. There's two or three things there in that little formula. There's chloride, which is the salt, and Australia is one of the saltiest nations on the face of the earth. We tend to reside around the coastal line, but also we have our great salt lakes and our dried salt pans in the middle of Australia. Salt is never far below the surface of the Australian continent. So we have salt, and the other one is, of course, stress. And the stress is due to having been put into a flight control system and tensioned up to 40 pounds tension. And it's under that stress continually, and it's in essentially a chlorine environment wherever it goes in Australia, more so on the coastal regions, but those are the two principal elements of chloride stress corrosion. The best way to inspect it is to pull the cable out of the system, marking where it's been with using masking tape, where it's been over the pulley or past fair leads, where the suspicious areas are, and using a 15x glass to go over those areas and see where the worn bits are. Look at every shiny bit, rotate it in a strong light so that you can see over every part of the surface, and then inspect those shiny bits and any other bits you like with, say, 10 to 15x glass with a bright light. And I would say stereo microscope's a nice, comfy way to have a look at it and be able to open up the cable, look inside it. That's the best way to inspect the cable.